Hi and welcome to the On Maths prediction for the Edexcel Maths GCSE Paper 2 for June 2018. Enjoy! Hi, I'm Chris Gilpin from On Maths. Now, what we do for this prediction is we take off all of the questions that came up in the Paper 1 and we look at the remaining topics and see how often they've come up before, both on the new GCSEs and on the old GCSEs, and we make a prediction. Now, like I said on the Paper 1 prediction, this is only used as part of your revision and not the sole purpose of your revision. So don't just look at this and leave it at that. However, as you might have seen with the Paper 1 questions, quite a few came up across the different exam boards, but our predictions get more and more accurate as we go on because obviously we now have seen the Paper 1, so you can make predictions for the Paper 2. All of our questions, all the questions you're going to see on this paper, you can do online on our website, onmaths.com. And if you go onto the website for free, you can either not sign up and just do the paper, and that's absolutely fine, or you can sign up and it will save your scores so you can try it multiple times, see if you can improve the scores. The onmaths.com also has topic busters, so you can practice every single topic. It also has demon questions for the harder style questions, and they're short little exams. They're only, I think, 20 marks, but they are just the toughest ones. And there's a whole load more things on the site. A new thing we're about to launch, so probably by the time you've seen this video, we have launched it, is the Revisionator. Now the Revisionator is only skills-based questions, so no difficult questions, we leave that for the demon questions. But what we've managed to do is take off all the topics that have previously come up and allow you just to revise a random selection of skills-based questions that might come up. So if you use the Revisionator, it will allow you just to focus on the topics that you need to focus on for the exam. So we're really excited to launch that. If you're watching this as soon as it comes out, it might not be launched yet, but hopefully it will be launched next week. So really looking forward to that. If you've got any questions or comments, please leave them in the comments tab below. If you like this video, please click like. And if you want to see more videos from us, especially the Paper 3 prediction, please click subscribe. I hope you enjoy. Okay, so the first thing to realise with this question is what perimeter means. The perimeter is the distance around a shape. Now, we've got a lot of x's and numbers, but it does say it wants an expression for the perimeter. So we're not looking for a number as an answer, we're looking for an expression, so letters and numbers. Okay, so there are a few sides missing, so I'm going to try and find out this side first. And to get this side, we're going to add the 5x here with the x there. So 5x plus x is 6x. So we've got that one. Now, if the total distance across is 7x plus 16, and the bit we know is 6x plus 11, then the bit we don't know we'll have to add up together to make the 7x plus 16. So we need another x and we need another 5. Okay, we've labelled all the sides. So what I'm going to do is pick a point on the shape and I'm just going to start walking around the shape and writing down everything as I go. So perimeter equals, and we've got 6x plus 11 plus 5x plus x plus 5 plus 6x plus 7x plus 16 plus x. So we've got quite a lengthy string of algebra there. Now we'll always need to simplify this. Okay, so if I collect the x's first, so we've got a 6x plus a 5x plus an x plus 6x plus 7x plus an x, which is going to be 26x. Okay, let's do the numbers next. So we've got 11 plus 5 plus 16, which is going to be 32. Okay, so the perimeter is going to be 26x plus 32. Now, a different way I could have done this is just focused on this one and doubled them. Now, let's have a look and see how that works. If this length here is 6x, then these two here would add together to make 6x. So in total, we have 12x going down. All the ones going across is going to be double this one. So it's all going to add together to make 14x plus 32. And then if you add those together, that would also give us the 26x plus 32. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'll use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0. And actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400. Okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now, 1.42 divided by 1 is just 1.42. So, the problem with this question though is that it wants the answer in pounds. So we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times, we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000, and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £2,112.68, and on my calculator I'm just going to type in 2,500 take away answer, and then press equals, and it gives me the answer of 387.32. So it's £387.32 cheaper. This question doesn't ask you to show the reasons for your working out, however most of the questions will, so let's try and make sure we write down some reasons as we go. The first one I'd go for is this one here, which I'm going to call A. Now I know that A is 180 take away 115, so 180 take away 100 is 80, take away 15 is 65 degrees, and the reason is it's angles on straight line. And if I know A, I know that B as well. So B is going to equal 65 degrees as well, because it's an isosceles triangle. All the bottom angles in an isosceles triangle equal, assuming that the isosceles triangle has the two same sides on the left and right. Obviously if it's rotated it's not the bottom two angles, but it's always going to be these two angles here. Okay, so B is 65. Now I can go straight to X. Because these are parallel lines, X and B create a Z angle, and we need to figure out what the Z angle is called, but we're going to say X is 65, it's the same as B. Now corresponding is the F one, interior or co-interior or allied angles are the C ones, so the one we've got left is alternate. They're alternate angles, they're Z angles, so the answer I can write is 65 degrees. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. The triangle we need to remember for this question is density equals mass over volume. Now you could have kind of worked it out with the question because it says grams, which is mass, per centimeters cubed, which is volume. So per means over, so it would be mass over volume. So we need to work out the mass. Well, at the moment we have the density, so we've got that. But we haven't got the volume, so the first thing I need to do is work out the volume of the prism. So to work out the volume of any prism, it's the cross-sectional area times the length. And some people call the length something else, but the length is basically how 3D the prism is. So the length is this one here, and the cross-sectional area is the area of this triangle here. So to the area of the triangle, we've got the base, which is 4, and the height, which is 9. So it's half times base times height, and then we're going to times it by the length, which is 10. So what have we got? The base, which is 4, so it's half times 4 times the height, which is 9, times 10. Now, the reason I know the height is 9 is that it hits the base at right angles, and that's really important. The base and the height must be at right angles. And don't forget to halve it. Now, what I can do here is something quite sneaky. What I can do is I do half times the 4 to get 2, and that saves me timesing some big numbers together just to halve it. So 2 times 9, which is 18, times 10, which is going to be 180, or you can just type it into the calculator if it's on the calculator paper. Okay, so that is in centimetres cubed, because every unit is in centimetres, and make sure you check that. So the volume is 180, so to work out the mass, if I cover up the mass in the diagram, so I cover that up, it says to work out the mass I do density times volume. So it gives me the density in the question, which is 5.5, and I'm going to times that by 180. So if I have a calculator, I can just type that in. Otherwise I could do 5 times 180, well I can do 10 times 180, which is 1800, then halve it, which is going to be 900, and then half times 180, which is 90. So that's 990. So the answer is 990 grams. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. Two minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry because this is a rectangle, that's a right angle, so I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse, so we're going to use sine, so SOH, so it's going to be sine 68 equals 27 over x, and I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough. But I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH, so cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. Okay, so in this question we've got a Venn diagram and we're supposed to fill it with all the numbers from the information shown at the top. So we need to go through the notation. Notation is pretty basic when you know what you're doing. This little E symbol here just means everything. That means those are all the numbers we're going to use in this question. Now it says that the A is all the multiples of 4. So we know all the multiples of 4 are going to go into A, but we can't fill them in yet because we don't know whether they're just in A or in that kind of overlap. So this is what the next piece of information is going to be. This little symbol here means and. Now if you think about it, with a little line across, it would say and. Okay, that means that those numbers are in both A and B. So actually we can fill those out now. So 16 and 40, they're going to be in A and B. Now we can cross them off from the list at the top, and actually we can have a look and see which other multiples of 40 are in that list. So 80 is a multiple of 40, so that's going to go in A, and 28 is a multiple of 40, so that's going to go in A as well. I think that's it. Okay, now we can't fill in the rest of them into B because they could be outside the Venn diagram. So we've got to just stop a little bit and have a think. So this last one says A union B. Now the union is just a posh way of saying or. It can be in A, it can be in B, it can be in both. So it's either in A or in B or in both. Okay, it's just in the Venn diagram. So let's have a look and see which numbers we haven't used yet in that list. So we've used the 16, we've used the 28, we've used the 80, we've used the 40. So we're left with the 1 and the 9. Let's cross that off from my list. So that leaves 47 and 3. So where do those go? Well, they go within the E box. Okay, and E stands for everything. So this is kind of our everything box. Nothing exists outside of here, for the purpose of the question anyway. And we just put them here. So it's not in the Venn diagram section, but it's still in the box. Now the last thing to do is just go through and check. Check that you've got the same amount of numbers in your Venn diagram than you should do. Check all the multiples of 4 are in A. So let's have a look. 80, 16, 28 and 40. They're all multiples of 4. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters. But do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4. And then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, So the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. What's interesting in this question is there's no amount. So what we can do it in two ways really. You could put an amount in, and it doesn't matter which amount you put in. So normally students go for £100 and then see how long it takes to get to £200, and that's absolutely fine. But you don't need to put amounts in, you can just work with the percentage that you've got. So how are you going to do that? Well, first of all, you've got to convert this percentage into a multiplier. We're going to start off with 100%. Compound interest is money you get, so it's going to increase by 5.8%. So that means that we're going to end up with 105.8%. To make that a multiplier, you just divide it by 100, so it's 1.058. So that is our multiplier. So year one, our multiplier is going to be 1.058. So 1.058. So we've increased it by 5.8%. To get year twos, all you need to do is 1.058, which was year one's multiplier, so after a year, and just times it by 1.058 again. And so I get 1.119364. Well, if you have a look at this bit here, it means it's increased by 11.9%. Well, we're looking to double the money, so we need it to be a 2 point something. So we keep going, and something you can do is you can press on the calculator answer times 1.058. And if you press equals, it will give you year 3, which is 1.184, blah blah blah. But all you need to do on the calculator is press equals again, and it will just do the times 1.058 to the previous number. So 1.252, so year 5, 1.325, blah blah blah. So it's going to take a while. 1.40. Let's scroll down a bit. So number 7, 1.48, 8 years, 1.56, 9 years, 1.66, 10 years, 1.75, 11 years, 1.85, 12 years, 1.967, blah blah blah. So we're getting close. And 13 years, 13 years, we get 2.081, blah, blah, blah. So 13 years is going to be our answer. Now, there's a few things just to note here. The first thing is that students tend to try and divide. They try and see how many 5.8s there are in 100 or whatever. Don't do that, because compound interest grows each time. So in the 5.8%, if you look at the numbers here, these numbers are increasing and increasing each time, and that's the beauty of compound interest. That's why people say save early. Start saving as soon as you're born. The second thing to note is you might be looking at it thinking, really, do mathematicians do that? Do they just have to sit and write them out? Well, no, actually there are other ways of doing it, but at this level, at GCSE, this is the method to do it. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach, which I'm going to use, is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it X, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine X over, so this is sine X, this is X here, so it's going to be over 8, equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8, so it's going to be sine X equals 8 sine 110 over 12, and then what I'm going to do is inverse sine both sides. Scroll down a bit more. So X is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that X is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator, and then what I'm going to do is add that to the 110 to work out what this angle here is, and I'm going to call that Y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as Y, just to make it a bit easier. So Y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that, then I'm going to type in 180 take away the answer. So that tells me that Y is 31.2104 blah blah blah. Okay, so I've worked out what Y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Where's A and B? A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Now, this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again. And then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like Capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. N, which is the population size, that's what we're trying to find out, is this, it equals M. Now, M is the amount of things that you marked and then released. So on our example here, we marked 4. Times N. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what m is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, well, you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831 So what this question is asking us to do is find the inverse function. That's what the f to the power of -1 means. And there's a really easy way of doing this. If we rewrite the function as y equals 4x minus 5, to find the inverse of it, we just literally swap the y and the x around. So x goes here and y goes here. Then the task is to try and get the try and get the y equals. Okay, try and make y the subject. So I'm going to put my lines down. So the first thing I need to do is add 5 to both sides. So we're going to have x plus 5 equals 4y. And next thing I need to do is divide by 4 both sides. And the way of doing that really is just with a fraction. So y is x plus 5 over 4. Now we made up y. Y represented the function initially, and then it represented the inverse function essentially. So all we need to do is finish that off. So f to the power of -1 of x equals x plus 5 over 4. If I just put that into the answer box. Now there are other methods, but I've always found just writing y equals and swapping the x and the y around and making the y the subject by far the easiest method. But if you've got a different one and it works, stick with it. Okay, so this question is involving a probability tree diagram. And if we read the question, it says that the counter's not put back in the bag. Therefore, we know it's going to be conditional. Now, conditional means that the probability of the second event, so taking the second counter, depends on what you did the first time round. Okay, the way probability trees work is you start on the left-hand side, and you have an option. You can either go up if you pick blue, or down if you pick red. Now, because you have to pick one of the options, the two options have to add up to 1. So if blue is 3 over 7, the bottom one must be 4 over 7. Has to be, because then it adds up to 7 over 7, which is 1. Now if we picked a blue on our first counter, the probability of us picking a blue again is 2 over 6. So therefore the probability of us picking a red will be 4 over 6. Okay, now let's see where those numbers have come from. It says in the question that there are 3 blue counters and 4 red. Therefore, the first probability of a blue being 3 over 7 is because there's 3 blue counters and there's 7 altogether. The second probability, so if I picked a blue on the first counter, went down, well, if I picked a blue again, to 2 over 6. That's because there's 2 blue counters and only 6 left altogether. So we need to know that to be able to fill out the bottom one. So if I picked a red on the first time round, what's the probability I'll pick a blue? Well, let's have a think. There are still 3 blue counters in there, but there are only 6 left altogether left in there because we've picked a red. So, the probability of us picking a red, well, there were 4 before we picked one, but we've picked a red, so therefore there are 3 reds left and 6 left altogether. Now, I'm deliberately not cancelling these down. I could cancel it down to a third, 2/3, half, half, but I'm just going to leave it as it is for now, just to make things simpler. Okay, question B says, work out the probability that the 2 counters picked are different colours. So let's follow our routes along. I'm going to go up and then up, so blue and then blue, blue and then red, red and then blue, and you're always starting from this point here, and then red and then red. Now, let's have a look. Blue and blue are not different colours, so we're not interested in that. Red and red are not different colours, but the middle two are. So, what you do with probability trees is you start here and you collect all the fractions that you went past on your way, on your journey to the end. So, we went past 3 over 7 and 4 over 6. Now, the word and there is really important because and in probability means times. And you're always going to multiply them when you're going across a tree diagram. So I'm going to times the tops and times the bottoms. Again, I'm not going to bother cancelling down at this point. Okay, so the other option is I pick a red first and then a blue. So that is 4 over 7 and, mean times, 3 over 6. That's going to be 12 over 42. And normally these two will be the same. Okay, so just be prepared for that. Not always though. Okay, so we had 12 over 42 for the first option and 12 over 42 for the second option. But we can't pick both options, and this is the problem. We've got two probabilities, two answers. Well, we can't possibly have that. The word or comes into effect here. We either pick a blue and then a red, or a red and a blue. And the word or in probability means add. So all we need to do to finish this question is add the two options we had. So when you're going down here and you're collecting all the fractions you got, you just add them together. So we're going to add the tops together, which is 24 over 42. So it's half top and bottom, and let's cancel it down now. 12 over 21, and I think I can divide them both by 3, so it'd be 4 over 7. So my answer is 4 over 7. Okay, so this looks like it's a kind of quadratic question, but it looks a bit of a mess. There's a really easy first step to sort this all out, and that's to times everything by y squared. So just times literally everything in the equation by y squared. So 5 over y squared times y squared just leaves 5. And here we've got 7, and in fact I'm going to write this as a fraction still so we can see it a little bit clearer. So we've times that by y squared, but we've not really dealt with it yet. And we've got minus 3y squared equals 0. Now the y at the bottom and one of the y's at the top cancel. So we end up with 5 plus 7y minus 3y squared. And since we'll use the quadratic formula on this, it's probably easier I put it in order. So that would be minus 3y squared plus 7y plus 5 equals 0. So we've got to find out what a, b and c are. A is the number before the y squared, which is minus 3. B is the number before the y, which is 7. And c is the number on its own at the end. Then we're going to use the quadratic formula, okay, which is x equals minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I'm just going to type that all into my calculator. It's a lot easier doing this than going through. I'm going to do plus first, and then I'm going to go back and change that. So minus brackets 4 times minus 3 times 5, close brackets over 2 times minus 3. Press the equals, and I've got an answer of minus 0.57338, blah blah blah. To two decimal places, that's minus 0.57. I'm going to go back on my calculator and change that plus to a minus. And it also equals 2.9067, blah blah blah. So that's going to be 2.91 to two decimal places. And so the trick with this is just convert it into something y squared plus something y plus something equals 0. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on an uncalculated paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. that goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right. The step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now, the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, all right, 35, it's 25. 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence, I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3, and that tells me, so I'll say linear. So that's going to be a 7, so we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. Okay, so for this question, this is all about linear, area, and volume scale factor. So, with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4. So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor. Okay, so this question seems really complicated because the just sheer amount of words, but actually it's quite a simple question when you get your head around it. So the first question, we're looking at a bag or 2 bags of letters and 1 bag of numbers. And so there are 26 letters in the alphabet, so there's 26 options for this first bag. There will be 26 options for the second bag, and numbers from 0 to 9. Now we've got to be careful here because 0 is counted, so there are 10 numbers in that bag, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's also 0, so that's 10 in total. And to get the amount of combinations, all we do is 26 times 26 times 10. And we'll have a calculator for this, so 26 times 26 times 10, which is 6,760, which seems quite a lot, but there we go. This next one is, so he wants to use 4 digits, but limit the combinations. So we just got to read the question. His letter bags now contain the letters A to F, so that's A, B, C, D, E, F, which is 6. So these both will contain 6. And only contain even numbers greater than 0. Now, these are the same bags as before, so we only had the numbers from 0 to 9 before. So the even numbers that are greater than 0, so it's 2, 4, 6, 8. So there's 4 combinations. So there's 4 numbers those can be. And so find out how many different passwords if they're arranged like this. So 6 times 4 times 4 times 6. So 6 times 4 times 4 times 6, which is 576. Now that might seem confusing that there's an extra digit to the password and yet less combinations, but if you think about it, there's significantly less letters and less numbers, so that's why it's a much lower number than part A. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from ka to ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9, because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, But the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was us, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3, and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed, so 5 times 3 cubed is 135, so I know I've got it right. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these calculators, these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. First thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now, at A level, there are much easier ways of doing this, but we at GCSE have to do this using the Trapezium rule. Now, the Trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually using the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because a and b are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area, so this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate.
Thank you very much for watching this video. Hopefully you found it useful. Don't forget you can go onto our website onmaths.com, which I'm sure the link will appear above me, to practice this paper and practice other papers as well. We've got all the previous year's predictions as well, which might be useful. And also we've got the new revisionator coming out, so we're really excited. If you've enjoyed this video, please click like. If you want to see more from us, especially paper 3, please click subscribe. Thank you very much.